Every year, every day for that matter, more and more software is going into the world. So this is the tsunami of code. And this is causing a lot of challenges and stressing the pipelines. Things that were working a few years ago are struggling to work today.
If up until now manual governance was an option, it is not. It just no longer is. We need a built-in compliance that has continuous control that we can work it throughout our SDLC. And when I say someone, it's the system. It's not a manual process that someone does.
Well, good day, everyone, and welcome to this special webinar co-hosted by JFrog and Gradle Technologies. I'm your host, Oliver White, and joining me today is an existing friend and a new friend. My existing friend is Java champion and Gradle developer advocate Brian Demers. You may remember him from such appearances as most Gradle webinars. My new friend is JFrog senior product manager Sophie Starchenko. And by coming together today as co-hosts, we're going to talk about continuous GRC, that's governance, risk, and compliance, for DevOps. Or, as JFrog has coined it, DevGovOps. Namely, why development teams who've thought little about security and compliance in the past need to begin to prepare for what's coming. As you'll see, Sophie and Brian are going to explain how, like traditional DevOps, GRC is now also shifting left, and developers are becoming more involved in securing their software during development. If you've been following any of the recent NX and NPM supply chain attacks, then you'll know why this is important.
Here's the deal, right? So every year, every day for that matter, more and more software is going into the world. If you write software, hopefully you don't disagree with me. Every once in a while I come across somebody who's deleting more code than they're adding, which is awesome. But for the most part, those are rare cases and everybody's adding code, right? So maybe it's hundreds of thousands or millions of lines of code, depending on the size of the shop you work at. But more and more code is going into the world, right? And of course, fast forward to the last year and a half or so. AI coding assistants or AI anything really is really exacerbating the amount of code we're adding. Both the number of commits, the size of the commits, the speed that you can do your work, all of these things are increasing. And it's going to keep increasing over the next few years, if not indefinitely. So this is the tsunami of code, right? And this is causing a lot of challenges, particularly around pipelines and stressing the pipelines, right? So things that were working a few years ago are struggling to work today.
So basically, governance is a set of policies that you need to align to your business standards so that you will be relevant in the framework that your business wants to align with. Then there's the risk management, which means we need to identify and reduce the risk as soon as we can, because we can't let the business be impacted by it. And then there's compliance, which is a big word that is exploding now in our world, which is the frameworks and the rules that we have to follow from a legal perspective, from a business perspective, if we want to sell in specific places, in specific industries. So if up until now manual governance was an option, it is not. It just no longer is. And it means that all of the human reviews, the legacy checks, what we thought we can manage with, just can't keep up with everything that AI generated, with the volume, with what we really get there. And so this poses a problem. And so that's a collision between three expanding forces. On one hand, we have the velocity, which is growing 10 times more. The code volume is enormous. If we take what was relevant 5 years ago from our deployment velocity and what is happening now, or even what was relevant a year ago, this is just that's not the same scale. And on the other hand, our attack surface is growing. We have a 300% increase in software supply chain attacks from all of their perspectives. And then the real gap is regulation, because customers or auditors are the ones to find your problems, because 3/4 of them, 76%, are discovered post-deployment, which is way too late. And at the end, all of this has a penalty and a financial risk, because under the CRA, for example, there's a 2.5% of your annual turnover penalty for non-compliance, which means If you want to be a relevant vendor in Europe, you have to find the solutions to make sure you are compliant. And so when all of this happens and the manual checks are failing, we need to find a solution. So Brian, what is the solution?
It's the same as it's always been, right? Automate all the things. I looked up this meme, and the original meme was clean all the things, but that was from 2010. So I think the automate all the things was relevant then, and it's obviously more relevant now with the way things are going. Right. So a quick story about the hassle that I think some folks still go through today. So this happened to me a few years ago. I had to go through a security review. Right. So it was a manual process. I was writing some code. So I got done. We were ready to ship the product. And then I had to create an issue, assign it to our security team. And then I waited a few days. Right. And then they picked up the issue. They ran some analysis tools against that. I think it was grepping for the word password, right? But yeah, it was probably some sort of security scanners. And a few days later, they let me ship the code, right? Everything was fine. So that was a multi-day process, manual process in the middle of me trying to ship our code. That was painful then, right? And if we needed to do that on every release, we would never get anything done. So fast forward to today, right? With the rate of delivery increasing, as fast as it's ever been, those processes just don't scale. To be fair, those processes didn't scale a number of years ago. They definitely don't scale today, right? So if anyone has those types of problems or those types of stories, let us know in the chat if you're still dealing with them. Hopefully you're not, but my guess is there are a few folks that are. But really, a lot of us are under a lot of pressure, like from our executives or whatever, to realize the gains from AI, right? There's a lot of money being spent here. There's a lot of pressure being put on everybody to write software as fast as you can. And many of us are, right? Many of us are seeing these gains already, which is great. And we're going to continue to add more folks to that party. But if we're not actually shipping code any faster, right, those gains don't actually matter. Right? If I could write code in half the time, but it still takes me the same amount of time to ship roughly the same volume of code to my customers, then I'm not actually seeing any gains for the business.
Yes, and basically that's the shift to DevGovOps, because the DevOps itself, what we knew before, is not enough. And the key is automating the software governance, because what we have today is like this friction between the shipping risk and the shipping late risk. Because on one hand, I have to move fast. On the other hand, I need to play safe, because I cannot get that penalty. I cannot screw up my compliance, etc. And the data today is siloed. It takes manual collection. It takes an auditor to come for us to really understand what's going on. And that's not good enough. We need to automate it. We need a built-in compliance that has continuous control, that we can work it throughout our SDLC and make sure that everything that got to deployment is something that I feel comfortable that if I'm audited on or if something happens, it will hold. So basically, that's what JFrog AppTrust does. We automate governance with evidence-based policies. So we have these three pillars. The first one is the application, which is the business entity that takes the risk and aggregates it for you to be able to understand not only is this artifact, is this package, is this binary, is this version relevant, but how is my whole business entity doing? The second one is we're integrating evidence, which is this immutable proof. And that's the important part, because it's supposed to be immutable. We need it to be signed. We need to be able to verify it. I really need to say, hey, what you see here is what really happened. I did my quality testing. I did my security scans. I have this critical build evidence from Gradle that I can later on leverage with my governance, which is something that we're going to show in the demo in a minute. And at the end, I want a single chain of custody that I know that it is what it is. Like, this is really what happened. And like, bring it all of this to circle back, like, okay, you have the evidence, you have the business entity. How do I govern everything? How do I automate it? So that's the thing. We want automated policy gates. We want something that as we go through our maturity levels of the release, we understand that it is being tested, someone is gatekeeping it. And when I say someone, it's the system. It's not a manual process that someone does. Okay, so as we discussed before, the first thing that we need to talk about is the business entity. Here it's the green elephant, since we're talking Gradle and JFrog. And it's important to say that it's not only the versions or the binaries. We have your business context, as we discussed like a minute ago. We have the business criticality. We have the owner, which means we know who is the person in charge. I personally put Brian because I like it when he is the one to blame, but we know who created this application, who is in charge of version being broken and what happens. We have the labels, which will showcase us like what is the specific governance this application needs. Maybe I have different set of rules for front-end application or for backend application or for something that's going into a Europe vendor or a US vendor. And then we go to the lifecycle, which is the different maturity levels my application version goes through. We have here the dev, the QA, prod, and we expect that as I go through the stages, it means that all of the checks, the testing I am supposed to do throughout this process are being done and are being created as evidence, which I will show in a minute. And also we go through the different gates. For example, here we put a gate on the production stage that shows that you cannot promote to production without having the build scan evidence from Gradle. This important information that Brian will show you in a minute in the system itself, but what I can prove that whatever went in my build, whatever happened there is really what I meant for it to happen. So what we will do now is that here is a pre-prepared version, and we will try to promote it to dev, and we will see that there are no gates right now here, only on the production, so everything is successful. And we can get into the dev stage. And basically this application version, this immutable entity, was created from one releasable, in this case, this package, the Java Payment Calculator. And we can also see all of the evidence that are attached to it. For example, here we have a signature evidence, something that looks like Gradle, but not an official Gradle evidence. And we can see that this immutable application version went through an SBOM scan, and we have the promotion evidence that tells us, hey, this was promoted to dev, as you just saw. This is when it happened. This is who did it. I can verify everything that happened. But as you saw, I don't have this official build scan evidence that we discussed before from Gradle. And now let's try to promote to the production stage. And we will see that it will fail because we have a policy violation. So we made sure that this version that is not working as we want our organization to work through regulation, it just can go to production.
Let's add some evidence, right? So for those not in the know, so I'm going to talk about what a build scan is too, if anyone is unfamiliar. But basically, we're going to take the data from a build scan, and we're going to use the Develocity Provenance governor to take that data and create that evidence or immutable, right, in the form of attestations and store them in JFrog. Right. So if you think about your build, right, it's the thing that takes your code and transforms it into the artifact that you're going to then use. Right. Without that process, it's just code sitting in a repository somewhere. It's the build that does this transformation, and that's a really important part of our SDLC, right? So if you want to start tracking provenance of your applications, it really, you can't do that without the data from your build, right? It all starts with your build, right? So through build scans, Develocity has this deep observability data from your builds and everything that went into it. How your dependencies were resolved, which dependencies you're using. And again, without these kind of insights, you don't know, you don't have this visibility into your build. Okay, so to give a quick example from, let's say, I think this was like a week and a half ago or so. So this was a Go CVE, but there's a vulnerability that was announced, and this was related to a compiler issue. right? Many of us here are probably Java developers, so I don't care about Go, right? But the same types of things apply, right? So if there was a vulnerability or even a performance issue in a version of a Java compiler, right? Do you know which version of the compiler that was used to build your application? Right, and the one that's you're actually running, you're probably running it and shipping it on a different JVM. Maybe a different JVM was used to build, right? But the same could be true for the plugins you used, right? Plugins could add things to your build. The famous was the XZ attack from a little while ago. You could have an annotation processor in your Java build that could change something. Maybe it's just a performance issue. Maybe it's not an actual vulnerability, but that's still going to cause a problem. So you need to be able to find this information and figure out what applications are affected. And again, this is kind of the weakest point of your supply chain, and attackers know this, right? And this is an area that we're seeing more and more attacks. All right, so this is a video. Hopefully I'm going to pause this and I'm going to walk through some screens here, but I'm going to fall back to my nifty video if all fails. All right, so I have this application. This is what Sophie just deployed or just moved through those gates. So this was the version without any evidence attached. So, here we go. My scrolling is working now. So I have this nifty little pull URL that's not super important for this demo. I like to put things like this in my build so I can actually, take what was built and then use it. In this case, it's building a Docker image. I have some build scan information I'll show in a second. But let's take a quick look at this workflow file to show there's no real magic here. Okay, so I have a few steps, right? We're going to check out the code. That's how everything starts. I'm using the JFrog CLI to exchange the GitHub OIDC token with the JFrog token, and then that's used later on when I set up Java, and then again, when I run my Maven build. I have basically a couple lines of code that adds that nifty button and sets up Develocity to capture build scans. So this build is already configured to do that. It is not configured for evidence. We're going to show that in a second. But it's basically just a Maven deploy, right? And of course, I'm using the Maven wrapper. And here's the nifty pull URL that I just added. Again, it's not important for this demo. Okay, so nothing really surprising here, but let's go look at that build scan real quick. So if you haven't seen a build scan, it's an immutable record of everything that happened in your build. Many of us on this call may be aware of this, but bear with me. Let me give you the nickel tour. You have basic things like console logging, right? So this is the types of things you'd kind of automatically assume you have in your CI logs. But they're in context. I can click on all of them, right? Any failures, timeline information. This is one of my favorite things, right? I can see profiling information, CPU usage as I go through my build and see where the hotspots are, and all the goals and tasks and things that ran. This is a Maven build, so it's goals. It was Gradle build. It would be tasks, right? And of course, dependencies, right? So that's everyone's thing to love most about software development is dependencies and dependency hell. Well, we have the dependency tree fully resolved and all the transitive dependencies here. And along with that, we know where they were pulled from, right? So in this case, there was 4 repositories used in this build. One of them is the one I would expect, right? This is the JFrog, the Artifactory URL that I push everything to. And then I have these other ones. I'm going to talk about that in a few minutes. But this is the typical type of thing you'd see in a build scan and want to really focus on. And of course, I also need to know which plugins and extensions and all those things I used in my build too. And then, infrastructure, right? This was built with Azul Java 17, for example. Okay, so that's the quick nickel tour of a build scan. So we're going to take this data and then we're going to turn it into immutable attestations. So I have this other build. It's already run, so you don't have to sit and wait, and twiddle your thumbs while we wait for a build to run. But let me show you the quick diff here, just to to show you what changed. So all I did is added this this GitHub action, and what this GitHub action is doing is using the Develocity Provenance governor to take information from a build scan and basically attach it to a subject. And a subject in this case is a Docker image, but it could be a jar, it could be, you know, Sophie mentioned binaries, any of those types of things you can store in Artifactory, right? The Develocity Provenance governor is going to handle all the signing, all of the communication for you from getting the bits from the build scan and getting them into JFrog. And of course, the only other thing, I changed the version, right? All right, so let's go back to the quick summary here. And we can see that I have 4 attestations published. I'm going to get to those in a minute. And, you know, we have my nifty build scan. I'm not going to get into this because it looks almost identical to the previous one I showed. But let's go to JFrog. All right. Okay, so the evidence for this artifact has been attached to a manifest JSON because it's a Docker image. You know, your manifest JSON is basically contains the list of layers of your Docker image. So that's the kind of the top point that you would attach something to. So we have evidence attached, and this is all from the build scan, right? And I'm just going to go through these really quick. I just showed you this data in the build scan, but now it's here as evidence. So this is a Maven build. I'm using 399. Maybe that's something I want to upgrade soon, but that's a different presentation. So there's a markdown view, and of course you can see the actual predicate that was signed. So the next one is Java toolchains. I showed before. This was using Azul Java 17. Right, and again, you can, if you were writing policies with Rego or whatever, you could use this view to see the actual data and see where it is in the object. Resolve dependencies. So this is again what I showed before. So you know, most corporate environments have rules where they want to pull everything from their local Artifactory or whatever your repository is. You know, either on network or in the cloud. You want to make sure everything routes through the same point. But this build has these other repositories attached to, right? So things could be resolved there. Now, in my case, these 3 repositories are actually very well trusted. It's great. It's not like a random repository finding on the internet, but there's still problems here, right? So these are snapshot repositories. There's Maven Central. Maven Central starting to rate limit folks. So we really should be funneling everything through internally anyway. But there's also a potential leaking of data depending on how your build is configured. So if I have all of these repositories configured, I could potentially be leaking my corporate group IDs and artifacts to that repository, right? So the less I trust the repository, the more I want to pay attention to these things. And the last one is the list of resolved dependencies. So this is very SBOM-like. But it's all the dependencies that were resolved in a flat list, so you can make policy decisions based on them if you want. And they're in Perl format. So if anyone is not familiar with the Perl format, it's the next greatest thing since sliced bread. So for Maven folks, right, it's the group ID, artifact ID, and version that we're used to seeing, but it also has this prefix. And you can imagine if this was an OCI image, that prefix would be slightly different, or NuGet or NPM or whatever. All of these are basically codified into a URI. So they're great. So go check it out. All right, so that is the bit of evidence that we've attached. Now I'm going to kick this back over to Sophie, and now that we have the evidence, let's get things pushed to production.
But before we like go to the next slide, what I want to say is that was like a great overview of the evidence we have, and I think that's like one of the main issues. You can decide in your organization how deep you want to govern. Is it enough that I just scan my build, like I'm showing in the demo today, to simplify the use case? Or I want to know that there was a specific tool used, a specific build, a specific version, a specific dependency or a repo that I don't want to allow to my developers to push through. So thank you, Brian, for the overview to deep dive into that. And now let's go back to the presentation and see what happens now that I have a package with this Gradle Develocity evidence. And so the most important thing to say is that there is this concept of a trusted release. A trusted release is a release that went through this release gate, through all of the policies that we believe are relevant to get to this golden repo, the last stage of our SDLC before deployment. And it is something that we believe that should go into production, should go into deployment. So again, here's a new version, and we will see the content graph again. And we have here the official relevant Gradle Develocity evidence. Again, the SBOM, because this is an immutable new version, we're scanning it. And I will, in this specific video, I just pushed it to production already and didn't go through the other stages. But basically, you can also govern that. You can say, hey, you cannot get to the prod stage if you didn't go through the QA stage, etc. And now we can see that we managed to get to production. And if we go again to the content graph, we have this new type of evidence saying, hey, this is a trusted release. And that's an important point because this is something that you can leverage in your deployment system. You can say, I only want to deploy something that has this evidence. So I will query them, I will verify them, and only then I will deploy. Yeah, we have a version in production.
Awesome. It's been shipped. The green elephant.
Mm-hmm. Okay. So we want just to wrap it up in like, what did we discuss? So the first thing is that manual governance is dead. We cannot keep up with the AI. We cannot keep doing these things by hand, by our developers and engineers, wasting time on taking screenshots and just hoping for the best. The velocity is expanding, which is the friction between, hey, I want to ship fast and I want to ship safe. And we need to do something about it.
Yeah, so build time data is critical for you if you're looking into software provenance or just general SDLC visibility, right? As we move into more automation or just in general, like we really need to know what's going on to optimize things or to troubleshoot or figure out the blast radius of an attack. So Develocity's Provenance Governor, again, supplies all of that signed immutable build evidence to JFrog.
And at the end, it's all about automating your GRC, automating the governance, automating the frameworks, saying, hey, I have this immutable evidence. I know exactly what happened. I can verify it. And now I can feel safe and ship.
Sophie and Brian, thanks very much for this excellent presentation. I think we got a very good overview of what's happening and where, and I wish everybody a very productive day.
Thank you.
Awesome. Thanks, everyone.